Mercado math, we're gonna do some math. Let's Merca do it. Hey guys, and today we're going to talk about special cases. Now these are still compound inequalities. You have an OR statement and an AND statement. But these are going to look a little different. These actually aren't considered special cases. These are just weird looking ones. So they don't fall under that special case category, but for most people they're going to be confused if you see this. The moment I see that OR statement, once again, the moment I see that word OR, I have an expectation of what this graph looks like. OR statements go out, like boat oars. So the moment I see this, this is what I expect. I expect a graph, and I expect these kind of circles to go out like this, like boat oars. That's the expectation. Now we got to graph it and see what actually happens. So when I graph this, same as an equation, 2x plus 5 to get that x by itself, minus 5, minus 5. That gives me a 2x greater than 6. Once you're there, we're going to keep going. We're going to divide by 2, and I get x is greater than 3. There's my answer. Now remember though, there's still this side. To get x by itself here, I'm going to divide by -3. Divide by -3. The whole chapter, I told you guys the main rule that you have to know is when you divide or multiply by a negative, we flip the sign. So I'm going to flip this sign and it becomes greater than or equal to. That cancels out. X, 6 divided by -3 is a -2. Then I have this answer. Now the thing that I told you before, when it's normal, is that right now it looks like I have two separate answers. Hell, I even boxed them individually. That really makes it look like there's two different answers. So I always told you put the word OR between them. Now, this is going to be that rare exception. That word OR is not going to work there. Because when we graph it, you're going to see what's going to happen. Remember, this is what I want to happen. I kind of want something like this to happen. I want it to be going out. At 3, it's an open circle. So here's 3. Open circle. X is greater than, that alligator mouth is open to x, so we go to the right. I don't have a ton of space, but I'm going to the right. At -2, closed circle. So here's -2. Closed circle. I'm going to color that sucker in. And x is greater than or equal to, so x is still bigger, so I'm also going to go to the right for this one. Now the problem is, I want it to look like this. It does not. I did not screw this up either. This is 100% correct. This all comes down to what the hell the word OR means. If I want apples or oranges, I just need one of them to be happy. That's it. Apples or oranges, I just need one. So what you're looking for is just where is there at least one of a graph. And if you look, there's one here. It starts 1, 1, 1, 1, 1, and then you have 2 here. That's not a problem with an OR statement, because once again, if I want apples or oranges, apple or orange, if you give me both, it's not wrong. It's not exactly what I asked for, but it's not technically wrong. I'd be happy. So our answer is just this. It's, oh, I have black there already. Let's go green. It's from that -2 on this way forever. That is my answer, just that piece. So my answer is just this. I don't actually need this. I did this work, but my answer is just that. From -2 on is okay. -2, bigger, will work for both of these. Okay, once again, it's an OR statement because it has at least one thing. Remember, an OR statement, you need at least one to work. Now this one's a little different. If you look at this one, this is an AND statement. This was an OR, this was an AND. It's the same damn work though. It's still the -3 less than or equal to 6. It's still 2x plus 5, 11. It's the same problem. All I did was switch the OR and AND. And once again, when I want an AND statement, I want them to go towards each other. I expect them to go at each other. Okay? So my expectation for an AND statement is this. I kind of want something that looks like that, open, close circles, but I want them going towards each other like that. That's what I expect when I get an answer. If I don't get that, that's a problem. So, same crap. I'm literally going to do the same work. Minus 5, minus 5. I mean, I'll do it all again. Minus 5, minus 5. We're going to do this one kind of quick, though, since I just did it. X greater than 3. Divide by negative 3, divide by negative 3. X greater than or equal to. Remember, I flipped that sign. Negative 2. And if you look, it's the same answer I had there before. I erased that sucker, but it was still the same. Now, for an and statement, usually there's a whole special way to write it. You put the small number on the left, the big number on the right, some less than signs, X in the middle. But for this one, let's see what happens. So, let's go pink. I'm going to go to 3. And it's going to be the same graph we had. Here's 3. Open circle, X is bigger, I go to the right. At negative 2, there's negative 2. It's a closed circle. X is bigger, so we're going to go to the right again. That's what that graph looks like. And it's the same graph I had here, if you look. It's the same graph I had here. Because it's the same problems. The only difference is that or and and. And now it comes down to, once again, what the hell does the word and mean? Now, if I want apples and oranges, I want them both. I need the two things. And that's what this means. I need both of these graphs to overlap. I need two of them. And if you look here, there's just one of them. That's one line. That's only one piece of the graph. And then right at this moment, right here, you'll see there's two of them. That's what an and statement is. An and statement is both graphs on top of each other. You want both of them. I want this graph and that graph. Or a statement's just one of them to work. That's it. You just need one to be okay. So for this, my answer is not going to be that graph. It's just going to be from here going to the right. That's that graph. So I don't actually need this one. Which means my answer is just that greater than 3. So the reverse, I don't actually care about this one. My answer is just X greater than 3. Okay? And if you look, that's the different sides. For this or statement, I kept this one. For the and statement, I kept the other one. Same work. It's all about knowing what the hell and or means. Okay? And I said, if you know what and or means, you're set. If you don't know what they mean, figuring it out in math is going to be kind of weird. So we're going to do, like I said, these aren't necessarily special cases. These are just weird versions of these problems. And we're going to stop here. All right. Hey guys, these are special cases. These are the ones we have to be careful with. So once again, before I start any sort of compound inequality, I have an expectation. I expect or statements to look like this, go out like boat oars, and statements to look like this, to go towards each other. That's the expectation. If that ever doesn't happen, it's going to be a little weird. Something weird happens. And that's what we just talked about before. The weirdness, if it doesn't match these, they're going to be a little different. So this first one, it's an or statement. It's going to solve them both. This is a two-step to get x by itself. Minus 3, 5x greater than negative 15. Same sign, add, keep the sign. From there, we're going to go divide by 5. Divide by 5. I get x greater than negative 3. For this one, negative 8. Negative 8, we're going to subtract 8 from both sides. And just like that, I have x by itself. X less than equal to 2. Now, normally, on an or problem, I would just write the word or between them, and I'd be done for the most part. That'd be my answer. This is a special case. So when I graph it, you should see exactly what's going to screw us up. This is an or statement. Keep that in mind. Or, that's what it should look like. Negative 3, it's an open circle. There's negative 3. Open circle, greater than, I go to the right. At 2, it's a closed circle. There's 2. It's a closed circle. We're going to color that sucker in. X is smaller because the mouth's open to 2, so 2 is bigger. X is smaller. Small numbers go to the left. And I'm like, ah, crap. that does not look the same. I'm expecting an or statement. This is an and statement. This has that overlap, that little double of the lines. That's an and statement when you have a double. Which means this or statement is an and statement. Now, if you think about what the word or means again, you can actually figure out the answer. That's always the way I did it. So I'll give you the rules at the end. The rules are confusing if you actually try to memorize them. It's either just know what the hell the word means. Or, apples or oranges. I want one or the other. I'm okay with both, but I just need one to be happy. So you're just going through the graph and going, all right, where is there at least one graph? Where's the graph going? And if you follow along, the entire number line has the graph on it. This is going left forever. This is going right forever. And in between here, you get both of them. So that's not necessarily wrong. I can have apples and oranges, and that works. But here you're just getting apples. Here you're just getting oranges. Here you're getting both. So this is an or statement where everything works. This is all real numbers. If you remember the symbol for that, that's that little double R that some of you were terrible at drawing. Or all real numbers. Same crap. And that's all you got to know. It's an or statement that looks like an and. It's all real numbers. Okay? Now, this one. I feel like if you know that this is an or that looks like an and, you can almost predict what's going to happen on this one. Here's an and statement. Hint, it's going to look like an or. So, same crap. I'm going to get that x by itself. Minus 5, minus 5. There's now a negative 2x. Less than, that's negative 12. Same sign, add and keep the sign. I'm going to divide this little sucker by negative 2. And the big rule from the chapter, when you divide or multiply by a negative, we flip the sign. So this is going to become a greater than sign. Negative over negative is a positive 6. One step there, you got to love a one step. Divide by 8, and this one is done. X less than equal to negative 4. I don't flip the sign on this one because I divided by 8. Just because you divide and you see a negative, don't go crazy flipping signs, all right? I divided by 8. No flip. Here's my graph. Here's my answer. I'm ready to graph. And when I graph, like I said, this is a special case. Something weird is going to happen. My expectation is an and statement. They're going towards each other. X is greater than 6. Here's 6. Open circle. X is greater than. It's bigger, so I go to the right. At negative 4, close circle. 1, 2, 3, 4. Close circle. X is less than. X is smaller. I go to the left. And I'm like, ah, crap, it's an or statement. Once again, it's an and statement that looks like an or. You can memorize the rule. The rule, like I said, is going to be confusing. I'll write it. They're going to sound the same. It's always drove me nuts. The easiest way to figure this out is, what the hell does the word and actually mean? Here it is. Apples and oranges, you want them both. You need both things to happen in order for an and statement to work. And the problem is, each of these is doing their own thing. You could have apples, or you can have oranges. There is no overlap. There's no scenario that I get both of these, okay? They're doing their own thing. So there's no way on this graph for me to get both of them. This is going left, this is going right. There is no overlap. I can't get both. I can't get numbers that are larger than 6 and smaller than negative 4. There's no scenario I can get both. So, I can't get it. This is no solution. And if you remember what the no solution shortcut looked like, you would just put the null set. Okay? And once again, you could write no solution, or you just write null set. They mean the same damn thing. These take a little bit of time, but these aren't like huge words. But if you don't want to write words, you got symbols. Okay? Now, once again, I've mentioned this before, all real numbers is different than infinite solutions. All your inequalities have been infinite solutions. X greater than negative 3. How many numbers are greater than negative 3? Infinite. Negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. There are infinite numbers larger than negative 3. That's not all the numbers, though. All real numbers means every number. Every number is not the same as infinite numbers. So that's one of those little things to be careful with. All right, now I'm going to give you the rules for this, and once you have the rules, we'll be good to go. Okay, so here are our rules for special cases. And if you look, they look so goddamn similar. This is why I never memorized this when I was your age. And statement that looks like an or statement that looks like an and. If you can memorize these without thinking about them, you're better than me. So I think about an and statement. If it's an and statement, I expect two things to happen at once. I expect that overlap. So once again, with an and statement, I'm expecting two things to happen. I'm expecting that graph to kind of have that overlap, the two of them. Then obviously, like I said, usually colored in between, but I'm expecting those two things. If it looks like an or, I can't get that overlap, which means I want two things to happen. I can only get one of each. I can't get both to happen. This is no solution. And like I said, that's annoying to write. I just spent more time on that than I wanted. You can just do the null set. When an or statement looks like an and, they sound identical. It's so annoying. But if you think about what an or statement, you want something like this. You're okay with one of each. That's all you need. You just need one of them to happen. You don't need both to happen. You just need one. And if it looks like an and once again, this is where the and, you wouldn't imagine that. You kind of imagine it goes like this, and it goes like that forever. So it's going forever left and right. It covers the entire graph. I just need one thing. I just need one thing to happen. That's it, just one. Here, you're getting one thing to happen over here on the left forever. You're getting one thing in the right happening, and then in the middle you get both of them to happen. So there's no scenario you're not getting one thing to at least happen. The entire graph will either have one or two things happening to it. So, everything is covered. This is all real numbers. And once again, I'm too lazy to write the word numbers. You can imagine how annoying it is writing that. Little double R symbol if you want. All right? Those are our special cases. All right? Now, let's see what I'm going to draw. That's a well because, well, you guys were able to do this. Well done, guys.